Hello all. Now we are going to see one of the important function of network layer, that is logical addressing or IP addressing. And this is used to assign IP address to the device that gets connected to the internet. And in internet, every device needs to be uniquely identified, and that will be done by using this IP address. We know what is the main purpose of computer network. Its main purpose is to have communication, that is to send the data from one device to another device. Now in internet, there can be so many devices connected. So to which device we want to send our data, that will be identified by using the IP address. So IP address is used to uniquely identify a device in the network. So this IP address will be unique and it will also be universal. So that means it is not going to have the same, you are not going to get the same address in one network as well as in the another network. Okay, so IP address is used to uniquely identify a device in the network. This is what we need to remember. And since we know that we have two versions of IP protocol that is currently in use, that is IPv4 and IPv6. So similarly, we have two versions of address, that is IP version 4 address and IP version 6 addressing. So in this class, we are going to see in detail about both type of addresses. So let us start with IPv4 address. The size of the IPv4 address is 32-bit, which means that the IPv4 address will have 4 bytes, since we know that 32-bit is equals to 4 bytes. And this 4 byte will be represented, can be represented in two notation, that is binary notation and dotted decimal notation, that we are going to see next. Now we have 32-bit to represent the IP address. That means how many possible combination we can have. Let us see that. So suppose if we had 2 bits with us. So if we had 2 bits, that means how many possible combination we can generate is, one possible combination can be 00, another one can be 01, 10 and 11. So that is, if we have 2 bits, then we are getting 4 possible combination. So how we are getting this 4 is by using this formula, that is 2 raised to power 2, which will be equals to 4. Suppose if we had 3 bits, then let us say if we are having the 3 bit, then how many possible combination we can generate is 2 raised to power 3, it can be 000, 001, 010 and so on. So that is going to give us 8. So if we have 3 bit, then we can generate 8 possible combination. So similarly, in the IPv4 address, we have 32 bit. So with 32 bit, we can generate how many possible combination? We can get 2 raised to power 32 possible combination. That is equals to more than 4 billion. So that means if we are using this 32-bit IP address, then simultaneously in internet, more than 4 billion device can be connected. Okay. So, but later we are going to see this is also not sufficient. Even though the fact is in internet at one time we will not have more than 4 billion devices simultaneously. We do not have till now, but still this many IP addresses that we have currently is also not sufficient due to some reasons that we are going to see later on. Now this IP address is unique as well as universal. I already discussed about the meaning of unique and universal. That is, unique means every device will get a unique IP address. That means no two device is going to get same IP address. So that means every device will be uniquely identified by using the IP address. Universal means the addressing system must be accepted by any host that is connected in the internet. So that means every device that is connected to the internet should understand the IP address or should be able to accept it and should be able to use it, okay, in the internet. So the IPv4 address is unique as well as universal, and the size is 32-bit, and because its size is 32-bit, we can assign or we can have more than 4 billion possible combination of IP addresses. So next we are going to see the representation, how we can represent this 32-bit IP address. So there are two notation. One is binary notation, the second one is dotted decimal notation. So in the binary notation, let us say this is my 32-bit IP addresses, that is in terms of zeros and ones. So this in total we have 32-bit, and as I had said previously that 32-bit is nothing but 4 byte. So how we are going to get 4 byte? Because we know that 8-bit is equal to 4 byte. So 8-bit is equals to 1 byte. So we can count from here 1, 2, 3, 4, 5, 6, 7, 8. So this 8 will give us first byte. Now the second 8-bit is going to give us second byte. Third 8-bit is going to give us third byte, and the fourth 8-bit is going to give us fourth byte. So this is the binary notation of IP address. Another representation is dotted decimal notation, in which every byte will be represented in form of decimal. Like if we convert this first byte, that is 1 and 7 times 0, then the value will be 128 in decimal. Similarly, if we convert the second byte, second 8 number of bit into decimal form, then we will be getting 11. Now third byte if we convert, then we will be getting its value as 3, and the fourth byte if we convert, then we will be getting its value as 31. So in dotted decimal notation, from the binary notation, you need to take byte by byte, and every byte you need to represent in form of decimal, and between the decimal values you need to give dot. So in terms of dotted decimal notation, the example is 128.11.3.31. So this is a IP address. Next we are going to see how to convert from binary notation to dotted decimal, and from dotted decimal to binary notation. Okay. So let us say we have in the binary notation, we have a IPv4 address. As I said, it is going to have 4 byte. Let us say those 4 byte are this one. Now let us convert this IPv4 address, which is in binary form, into the dotted decimal form. So how we are going to do is, this 32-bit we need to divide it into bytes. That is, after dividing into byte, we will be getting 4 different bytes. That is, this first 8-bit will have one first byte, second 8-bit, second byte, third 8-bit, third byte, and fourth 8-bit will be of fourth byte. Now convert every byte into the decimal. So how we can convert into the decimal form is, I think you have already studied about it. You need to multiply it by 2 raised to power the bit position. But in the simplest form, that will be used in network, and this will be very common. This example that we will be doing, how to convert, you need to use it very frequently in computer network, and this is what we are going to see next. Now this 8-bit, let us first of all just write it as 2 raised to power 0, 2 raised to power 1, 2 raised to power 2. So we are going to convert every byte to its decimal form, right? So for that, let us just write every multiple as that is 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 5, 2 raised to power 4, 2 raised to power 5, 2 raised to power 6, and 2 raised to power 7. These are the multiples. Okay. Now we know what is 2 raised to power 0. That is equals to 1. Then 2 raised to power 1 is 2. Then 4. 2 raised to power 2 is 4. So this is how it is going to look like. That is 2 raised to power 0 is 1. 2 raised to power 1 is 2. Then 2 raised to power 2 is 4. 2 raised to power 3 is 8. 2 raised to power 4 is 16. 2 raised to power 5 is 32. 2 raised to power 6 is 64. And 2 raised to power 7 is 128. These are the multiple value. Now what we usually do is we multiply every bit by its multiple. That is, in this example, if we see, the first bit is 0, so multiply 0 with 1. Second bit is again 0, multiply 0 with 2. This is how, and then we need to multiply, we need to add it. The result will be its corresponding decimal format. So now in this subject, what we are going to follow is, we are going to use this some shortcut mechanism. Whichever technique for converting binary to decimal you feel easy, you can use it. Okay. Now these are the, as I said, these are the multiple, and if all the bits value is 1, then you simply have to add all this multiple value, that is 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, which will be equals to 256, right? Okay, now using this technique, let us convert, and in this one just see where 1 is there. Okay, because multiplying 0 with anything and adding, it's going to give us value 0 only. So just find where you have 1 and just multiply that 1 with the this multiple value and add it. So in the first octet, in the first byte, we have 1 at the 7th location. So starting from 0, 1, 2, 3, 4, 5, 6, 7. So in the 7th location, the multiple is 128. So remaining all are 0. So if we convert this into the first octet into decimal, then the result will be equals to, since we have 1 in the 7th location, so that is going to be 128. So my first octet is 128. So give dot in between. Now take the second octet, which is 00001011. So for the first, in the 7th position, the bit value is 0. Next is also 0. Third is also 0. Fourth is also 0. Then after that you have 1011. Okay. So only take their multiple and add it. So we have 1011. So you will be taking only this 8 plus 2 plus 1. And if we add 8 plus 2 plus 1, then the result will be 11. So this is the corresponding decimal value of second binary bits, or the octet. Now take the third octet, which is equals to 0000011. So let us write this here. So what you have to do is take only the multiple of wherever you have 1, its corresponding value, and add it. So we have 2 and 1. So 2 plus 1, if we add that, then the result will be equals to 3. So this is the corresponding decimal value of third octet. And for the last octet, let us write it here. It is, we have 000 and all 11. Now wherever you have 1, just you need to take its multiple value and add it. That is 16 plus 8 plus 4 plus 2 plus 1. Okay. So this is going to give us value 31. 16 plus 8 plus 4 plus 2 plus 1. 31. So its corresponding decimal value is equal to 31. So you can compare it with the previous example that we had seen, which is equal to 128 plus 11 plus 3 plus 31. So this is what we are getting. So this is how we can convert, and you will be getting a lot of example to convert from binary to decimal and from decimal to binary. So you need to learn how to do it. Now if you need to convert from decimal to binary, let us do the same example here. Let's say we have decimal value as 128.11.3.31 and we want to get its corresponding binary. Okay, so take every octet one by one. Let us say my first octet is 128. So here also we are going to use the same multiples. Okay, just write this multiple, and you need, if you will be able to memorize it after doing 2-3 examples, so it will be easy for you. Now to get what will be the binary representation of this decimal, that is 128, simply write or find, okay, by what combination of this multiple we will be getting 128. So we already have 128, so if we make its corresponding bit as 1 and remaining all 0, then the result will be binary format of 128, which is equal to this one. Now similarly, let us take the second octet, which is 11. Now we need to get the binary representation of 11. So how we will be getting is just try to figure out which all multiple value after adding will give us value 11. Okay, so for that we can get, if we do 8 plus 2, so let us say we have this one 8 plus 2, that will be 10, and if we add this 1, then we will be getting 11. So you make it 1, then we are not taking 4, that will be 0. We are taking 2, that is 1. We are taking 1, so it will be 1, and remaining all 0. Whichever multiple we are taking, you give its corresponding bit as 1, and the remaining will be 0. So this 0, 0, 0, 0, 1, 0, 1, 1 is the corresponding binary notation of decimal 11. Similarly, let us see what will be the binary notation of decimal 3. So how to get 3? Okay, you just need to see this number and try to figure out. If we add 2 plus 1, then we will be getting it as 3. So in the corresponding position of 2 and 1, you just give 1, 1, and remaining will be 0. Okay. So similarly, the last one is 31. So how to get the binary representation of 31? Figure it out and find it out how to get 31. See, from this point we have 32 and more. So all this thing will be 0, 0, 0. Okay. Now remaining multiple we have is 16, 8, 4, 2, 1. Okay. So by what combination of the 16, 8, 4, 2, 1 we will be getting 31? That we need to figure out. Okay. So 16 plus 8 if we do, then that becomes 24. Plus 4, then we do, it becomes 28. Then plus 2, 30. Then plus 1, 31. So if we make all this as 1, then the result will be 31. So this corresponding is the binary representation of value 31. So this is how you need to convert from dotted decimal notation to binary, and from binary to dotted decimal notation. There are two types of IPv4 addressing, that is classful addressing and classless addressing. In case of classful addressing, this 2 raised to power 32 number of IP address, that is 2 raised to power 32 is equals to more than 4 billion. This is called address space. So the address space of IPv4 is 2 raised to power 32, which means we have 2 raised to power 32 number of IPv4 addresses. In case of classful addressing, this 2 raised to power 32 number of IPv4 address is divided into 5 class, that is A, B, C, D, and E. So how that division has been done is, every IP address that starts from 0, okay, if the first bit is 0, then that IP address we say it belongs to class A. Every IP address that is having first 2 bit as 10, then we say that it belongs to class B. Every IP address whose first 3 bit is 110, then we say that the IP address belongs to class C. Then in class D, all those IP address goes with first 4 bit as 1110, and in class E, the first 4 bit has to be 1111. So this is how this 2 raised to power 32 IP addresses has been classified or grouped into 5 classes. That is, this representation is when we have binary notation, but when we have dotted decimal notation, then those IP addresses in different classes can be represented as, if the first octet or the first byte of that IP address is in the range of 0 to 127, then the IP address belongs to class A. If it is in the range of 128 to 191, then the IP address belongs to class B. If it is in the range of 192 to 223, then it is in class C. If it is from 224 to 239, then it is in class D. And if it is from 240 to 255, then it is in the class E. So these 5 classes includes all these 2 raised to power 32 number of IP address. These 5 classes are also divided into 3 categories. That is, the IP addresses that belongs to class A, B, and C are the IP address that will be assigned to host. So that is used to identify a device uniquely in the network. IP address that belongs to class D is used for multicasting. That is to set a group of device into one group, and if we want to send a message to all the member of the group, then all the member of that group will have one IP address, that is the multicast IP address. And if we are using that multicast IP address, then the message will go to each member of the group. So class D IP address is used for multicasting, and class E IP address was reserved for future use, but though they never used it, until now it is free. Okay, there is no use of class E IP address till now. Now we will be assigning the IP address to identify a host uniquely in the network, and that will be done by using either class A IP address, B IP address, or class C IP address. Now this IP addresses of class A, B, and C is also divided into 2 parts, as you can see here with the yellow highlight. Now the first part of this IP address will be used to identify the network, in which network that particular device is. Okay, so that means all the device that belongs to that network will have same first part, and the second part will be unique for the host, that is used to identify that particular host. For example, let us say in the first part, if I have something like 128, let's say some other value, let's say 10. In the first part 10, and in the second part we have like 3 octet in this example, because we are taking 10 and it belongs to class A, so we have in the first part we can take only 1 octet. In the second part we will have to take 3 octet. That we are going to say afterwards. So in the second part it will be the address that will be identifying the host uniquely in that particular network. So every host or every node that is there in that network will have the first part to identify the network address, and the second part will be to identify the node in that particular network. So the first part is called network ID, the second part is called host ID. Now if we are using class A IP address, then the first byte will be used for network ID and remaining 3 bytes will be used for host ID. Similarly, if we use class B, then first 2 bytes will be used for network ID and last 2 bytes will be used for host ID. And if we use class C, then first 3 bytes will be used for network ID and the last byte will be used for host ID. Now with this configuration, what we have is, if we have class A, then only first byte can be used for network ID. That means how many possible network that we can have is, let us go back to the previous slide again. Now if we see here in this slide, then in class A, the first bit is fixed. That is, if IP address belongs to class A, then the first bit will always be 0. Now that means we can have the combination only from the remaining 7 bit. So 1 octet is equal to 8 bit. Now first bit is fixed, that is 0, so we are left with remaining 7 bit that we can change it. So if we make it all 0, and that we can give to one network, make remaining as 0001, give it to another network, again change the bit, the remaining 7 bit, you make any possible combination of the remaining 7 bit, and we can assign that every combination to each host. Now with this one, we are left with 7-bit whose combination we can generate. So with the 7-bit, the value will be equals to, if we are using 7-bit, the value will be equals to 2 raised to power 7, that is equals to 128. So that means if we use class A IP address, then this class A IP address can be assigned to maximum of 128 different networks. Okay. Now each network can have how many node, how many device? That is, since we have 3 octet as host ID, second byte, third byte, and fourth byte, that means this 3 combination is equals to 8 plus 8 plus 8. That is equal to 24. That will be equal to 2 raised to power 24. So that means class A IP address can be given to maximum of 128 different network, and each network can have 2 raised to power 24 number of devices. So this is what is this table representing. So class A, number of block or the number of network can be 128. Block size means the number of devices in the network, which will be equal to some value 16,777,216. Now this is a unicast address, one-to-one communication purpose we can use it. Similarly in class B. In class B, how many bits we have is, if we go back, in class B, the first 2 bit has to be 10. So the first 2 bit is 10, and remaining out of 2 octet, that is equal to 16 bit. Out of 16 bit, we cannot have the combination of first 2 bit, so we are left with 14 bit. So 2 raised to power 14 is equals to 16,384. So this many block we can have, and in each block we can have 2 raised to power 24 number of hosts, that is 65,536. So this is how we can calculate for class C also. In class D and class E, only first 4 bit are fixed, remaining 8 bit we can use to generate the different possible combinations. So why this classful addressing technique was used was, depending on the type of organization, an organization can ask for the IP address that will either belong to A, B, or C. Okay, let us say, for example, my organization has very less number of computer or device, that is less than 256. Then which IP address I'll be requesting for? I'll be requesting for class C IP address. Now similarly, if I have large number of devices, that is more than 256, then I can request for class B or class A. So this was to segregate based on the type of organization to give the IP address that will belong to either class A, B, or C. But this type of technique of dividing the IPv4 address into different classes had lot of problem, and the problem was the wastage of IP address, and this led to the depletion of IP addresses, which is a major problem in IPv4. Now what happened was, the type of division that was done, okay, this is the oldest technique, and the type of division that was done in this technique was, for example, I am a small organization, so that means I should be requesting for class C IP address, but usually an organization will have more than 256 number of device. So I'll be requesting for class B IP address, which can accommodate up to 65,536 number of device. Now, most of the organization will not have this many devices. Okay, not even 65,536 devices. So most of the IP address, even after me taking class B IP address, most of the IP address was getting wasted. Now if we see class A, it has around 16 million IP addresses, and there in this world there are hardly any organization having this many devices in their network. So if somebody taking class A IP address, lot of IP addresses was going wasted. So the main basic problem is, depending on the size of my organization, I'll be requesting for IP address, but the class C IP address will not satisfy my requirement. And if I take class B or class A IP address, then they have so many IP addresses in one group. So that means if I take that, then lot of IP addresses will be wasted. So there was a technique that was proposed for this one, that is subnetting. That is to take the, let us say, class A IP address, again divide the host ID into various group and give it to different organization. But that also could not be successful. So because of that, even though we have more than 4 billion IP addresses in IPv4, now if we use classful technique, then lot of IP addresses were getting wasted. So people moved from classful IP addresses to another type of IP address, that is classless IP addresses. So this is what we are going to see from the next slide. So in case of classless addressing, depending on how many IP addresses we want, we can request for only that many IP addresses. Let us see if I want 16 IP addresses. So I will be requesting ISP to provide me only 16 IP addresses. But when the internet service provider will be giving me the IP address, they will have to follow 3 rules. And those 3 rules are, the first one is all the IP addresses that they will be providing us should be contiguous. That means it has to be one after another one. Like for example, if the first IP address is 205.16.37.32, then the next IP address has to be 205.16.37.33. Then the next has to be .34, .35, .36, and so on. So this was the first restriction. Second restriction is the number of addresses in that block has to be power of 2. Like for example, if I want only 15 IP address, I cannot get 15 IP address. I'll be getting in terms of power of 2. So next value, that is in terms of power of 2, is 16. So I'll be given 16 IP address. So there will be very less wastage of IP address. So this was second restriction. And the third restriction is the first address should be evenly divisible by number of address. That is, in this example, let us say the number of address that is given to me is 16, and my first address is 205.16.37.32. So if I divide it by 16, okay, so if as a whole, if for that I need to convert it into binary, entire 32-bit, then entire 32-bit as a whole, not by taking octet by octet, as a whole I need to convert into decimal. That I will have to divide by 16. And after dividing by 16, if the remainder is 0, then we say that it is evenly divisible. So in case of classless, what happens is that as per the requirement of the organization, only that many IP addresses can be assigned, but with 3 restrictions. That is, the address must be contiguous, that is one after another. That the second one is the number of address in the block should be power of 2. That is, either it can be 1 address, or it can be 2 address, 4 address, 8 address, 16 address, and so on. And the third restriction is the first IP address that will be given in that block has to be evenly divisible by the number of addresses. Okay, so we will see the example about this now. So if we can see here that I want 16 IP address, so ISP provided me the IP address starting from 205.16.37.32, and in the contiguous manner gave us the 16 IP addresses, and it is satisfying all 3 requirements. So it belongs to a classless IP address. Now the second term that is important to us is mask address. So what is a mask address is? It is a sequence of 111 followed by 000. Okay, and the size will be of 32-bit. So there has to be continuous 1, and that has to be followed by continuous 0. Now how many 1 is there in that mask address, which is of 32-bit, that is going to define or give us the information about the network address and the host address of any IP address. So whenever we give or we talk about any IP address, we also have to write its mask address corresponding. Like for example, if I write 205.16.37.32, so this is one of my IP address. Okay, so taken like this one. So every IP address will have its mask address. So mask address is going to give us the information about the network ID and the host ID. So let us say for this example, so if I'm writing the mask address as something for example, let us say if I write 24, it means that we have 24 times 111 followed by 000. So in total it has to be 32 bit. So in case of classless addressing, this mask address will be written like this, that is /n. So this is what. So any IP address of that of the block, that is x.y.z.t/n. This is how we need to write, and this n represents the mask address. So this n is nothing but how many 1 is there in the mask address, and the mask address will have successive 1 followed by 0. In case of classful addressing, we know how many octet belongs to that is going to give us the network address, and how many octet is going to give us the host address. So finding its mask address is not difficult. Like for class A, first octet defines the network ID. So first 8 bit is 1 and remaining all bits are 0. Similarly in class B, first 2 byte is going to give us the network ID information. So first 2 byte, that will be 111 followed by 0. So if I convert that into the decimal format, then it is going to be 255.255.0.0. Similarly in class C, we know first 3 octet gives us the network ID information, so it is 1111 and the last byte is 0000. Now to represent the classless IP addresses, the block of classless IP address, we need not be writing entire block. Okay, that is, let us say here we have 16 IP address. We need not be writing all the 16 IP address. We need to write only one of the IP address. Okay, out of the 16, only one of the IP address followed by its mask address /n. So that is sufficient to give us the information about the network address, the host address, how many hosts are there in this particular block, and everything. So how we are going to calculate it is, there are two ways of doing it. The first way is, suppose if an IP address with its mask address is given to us and we want to get the first address of the block, then we need to set rightmost 32 minus n number of bit as 0. That is, for example, let us say we are given with one of the IP address, that is 205.16.37.39/28 is given. This 28 is the mask address. So what I need to do is 32 minus 28. That is equal to 4. So last 4 bit, you just convert this IP address into decimal, that will give you this value, and make last 4 bit as 000. So again converting back into dotted decimal, this is what this will be my first address in the block. Now to get the last address, you need to set rightmost 32 minus n number of bit as 1. So make this 4 bit as 1. The result will be last address of that particular block. So after setting the last 4 bit as 1111, we are getting the value as 205.16.37.47. So this is my last address in that block. Now we can also calculate how many addresses we have in a block, that is by using this formula, which is 2 raised to power 32 minus 1. So n, sorry. So the value of n in this example was 24, which is the mask address. So if I 28. So if I do 2 raised to power 32 minus 28, that is 2 raised to power 4, which is equals to 16. So that is the number of addresses in the block. Now next we are going to see how to calculate this mask address. As I said, from any IP address, given mask address also, we will be able to identify how many total number of IP addresses are there in that block, what is the first IP address, what is the last IP address. Okay. So how this mask address will be calculated by ISP and all. Now let us do this by using this example. Let's say that we have a ISP and which is granted a set of addresses starting from 190.100.0.0/16. So that means the ISP is currently having 65,536 number of addresses. So how we got the 65,536 number of IP address? That is by using the mask address. 2 raised to power 32 minus 16 will be equal to this 2 raised to power 16, which is equal to 65,536. Now this ISP is going to distribute this many IP address into 3 customers. The first group of customer is currently having 64 customer which each need 256 addresses. Second group has 128 customer each requiring 128 addresses. Third group has 128 customer each requiring 64 addresses. Okay. Now we are going to divide these IP addresses into each customer. This is a classless addressing that we are doing. Now in the first group, since we know that we need 200, we have 256 addresses. Sorry, we need to give in such a way that the 64 customers should get, each one should get 256 IP addresses. So 256 is nothing but if I convert it into the value of how many bit will be required to represent this 256 is, we know that 2 raised to power something should be equal to 256. Now what is that something we will be getting is by taking log in both sides. Okay, so take log in both sides. That is going to give us log 2 of 256, which is equals to 8. So what I'm trying to say is that in the first group of customer, each customer required 256 addresses. So that means how many bits out of 32 bit, how many bits should be given for host ID? Okay, that the customer is going to change those bits and assign each to each device. So 256 requires how many bits? That is what we are currently calculating. So to get 256 possible combination, we will be requiring 8 bit. So how we got it is by taking log of 256, right? So that means out of 32 bit, we will be requiring 8 bit for host ID. So 32 minus 8, that is the result is 24. So we will be requiring 24 bit. We are available with 24 bit to define the network ID. Okay, and what is subnet mask? Sorry, what is the mask address? Mask address is the sequence of 1 followed by sequence of 0, and how many 1 will be there? That depends on how many bit is going to define the network address. So we got here the number of bit that is going to define network address is 24. So its mask address will be equal to /24. /24 is the mask address. Now let us the ISP provider is going to divide the IP addresses like this: 190.100.0.0, that is the first address. Okay, /24 to 190.100.0.255, that becomes total 256. This many IP addresses will be given to first customer. Second customer is going to get 190.100. Since we are finished with the last octet, we need to now change the second last octet, that is 1 to 0 to 190.100.1.255. So that will be given to second customer. Just try to understand this figure. What we are doing is we are giving 256 IP addresses to total number of 64 customer. So that means how many IP address we gave is 16,384. Now similarly, we need to go to the second block wherein we have 128 customer and each customer require 128 address. So that means out of 32 bit, how many bit needs to be given for a host ID? That is 128 address. That will be equal to log 2 of 128, which is equals to 7. So 7 bit needs to be reserved. So we are left with, for the network ID, we are left with 25, which also means the mask address is /25. So we need to keep on assigning from the first customer to the last customer. Now here each customer requires 128 addresses. Okay, so that means the last IP address that was given to group A was 63.255. Now we need to start from 64.0. So 64.0 to 64.127, that becomes 128, and we have total 255 value in one octet. So from 64.128.255, that can be given to second customer. So this is how 128 customer is going to get the mask address. Similarly, in the third case, we have 128 customer requiring 64 address each. So log2 of 64, that is equal to 6 bit for host address, 32 minus 6, that is 26 addresses for network ID, and /26 is the mask ID. Okay, and this is how the allocation has been done. So we can see here in total the number of IP addresses that is allocated is 40,960, and if we subtract it, ISP is still having 24,576 number of IP addresses. Now once we get a block of classless IP address, we can also divide that block into various sub-blocks. Okay, so this technique is called subnetting. Like for example, I have an organization and my organization has been divided into 3 offices. So my organization has 3 offices. Okay, so I want to divide that block of IP address in 3 groups. So how that can be done is, let us understand this using this example. Let us say one of the IP address of my organization, it can be any value, any IP address from that block. So one of the IP address is 176.37.96.54/26. Okay. Now from here, let us first of all find out how many IP addresses that my organization is currently having. So how to calculate it? We just have to use a formula, that is 2^32 minus 26 mask address. So if you do 2^32 minus 26, that is equal to 2^6, which is equal to 64. So from this only, okay, just by looking at one of the IP address with the mask address, we can figure out or find out many other information. Like one of the information by using the mask address we got is how many IP addresses my organization currently has. Now my organization is again having 3 offices. So I want to give the IP addresses to these 3 offices. So how it will be given and what will be the mask address? Okay, what will be the starting IP address? What will be the end IP address in each office? That we need to calculate it. Now, in the first office, let us say we have 32, we require 32 IP address. In the second office, we require 16 IP address. In the third office, we require 16 IP addresses, for example. Okay. So in the first office, we need 32 IP address. So that means what should be the mask? Mask should be 2^32 minus, let us say N1 is the mask address of first office. So 32 minus N1 should be equals to 32. We need 32 IP address. So what will be the value of N1? So it is going to be equals to, you need to take logarithm in both sides and then calculate it, or what you can do is, this 32 you write it in terms of 2^, which is equal to 2^5 equals to 32. So you do 32 minus N1 equal to 5 and find the value of N1. So that will be equals to 27. So for the first office, my mask address is 27. So this is my subnet mask. The original mask of my organization is /26. Now for that particular subnetwork, my mask address is /27. Similarly, we can calculate for second office, which is equal to 2^32 minus N2, that should be equal to 16. And this 16 can be written as 2^4. and if we equate it, then the value of N2 we will be getting will be equals to 28. Similarly, for the third office also, the subnetwork mask is going to be 28, so /28. Even though we are using this subnetting technique, we are using classless addressing technique, then also this 2 raised to power 32, that is the address space of IPv4, which is more than 4 billion IP addresses, is not sufficient in today's requirement. So the another technique that was adopted is called network address translation, and this is one of the very famous technique, and it is being used in most of the organization, and that is the total 2 raised to power 32 IP addresses. Out of that many IP addresses, some of the IP addresses are classified into private IP address. And what are those IP addresses is the IP address starting from 10.0.0.0 to 10.255.255.255. That is, in total we have 2 raised to power 24 IP addresses, and another set of IP address that is 172.16.0.0 to 172.31.255.255, that is in total of 2 raised to power 20. And the third set of IP address that is 192.168.0.0 to 198.2.168.255.255, which is equal to 2 raised to power 16 number of IP address. So this many IP addresses, okay, with these ranges are classified into private IP address. Now, what is the significance of private IP address is an organization internally can use any of this IP address without buying. Okay, you need not register this IP address to any ISP provider. You need not buy. All this IP address has to be can be used by any organization. Like for example, if I have 2 raised to power 16 number of computers, then let us take the third range and assign this to all my hosts. Okay, now this IP address, private IP address, they have to be unique within an organization, but they need not be unique throughout the internet. So that means in internet there will be large number of organizations connected. Now within that organization they are going to use these private IP addresses. Okay, so that private IP addresses is unique only within the organization, but in between the organization or throughout the internet, this IP address is not unique. Now, how this uniqueness will be achieved is by using the technique of network address translation. So how this network address translation works is, within an organization, the organization will be using this private IP address. Okay, that means between the organization they are not unique. So many organizations will be using the same set of IP address. But how it is made unique throughout globally is by using the concept of NAT. Now what happens is that, let us see if this is the organization and they are using the private IP addresses, that is 172.18.3.1, and then in this range they are using. So the organization will have one of the router to represent that organization to the outside world. Now that router is called NAT router, Network Address Translation Router. Now this router will be the representative of the entire organization. So any data that goes out of any of the device from the organization to the internet will have to go through this NAT router. Similarly, any data that the internet is sending to any one of the device of the network will come from the NAT router. So how this is going to work is, the NAT router will be given the IP address, which should not be the private IP address. So that means that NAT router, whichever IP address it has got, will be unique throughout the internet. So an organization is buying only one IP address, that is unique IP address for the internet, and the organization can have any number of hosts within it, and for all those hosts it will be using the private IP address. Now whenever a device sends a message to any other device in the internet, then the message will go through the NAT router. NAT router will do the appropriate translation and will be forwarded to the device. Similarly, when this device wants to send any information back to this node, it will not know the private address of the exact sender, but it will only have the information about the address of the NAT router. So this device will be sending the data to the NAT router, and NAT router will have a table that is called address translation table, and from there the NAT router will be able to identify that the message should go to which particular device. That is, for example, let us say the device having IP address 172.18.3.1 is sending a message to some other node in the internet. Now when the NAT router gets this message, it will be changing the private IP address to the IP address that is assigned to that router, and the message will be forwarded. Now for the other device, it will assume that the source is this particular node having this IP address, so it will be sending reply to this node, and in the reply message the destination address will be the address of the NAT router, which will be converted into the actual destination address, that is the private address by the NAT router. So for that, the NAT router is going to use a table. So every outgoing packet information will be saved in the table, and for that the incoming packet will be converted accordingly to find the exact destination. Okay. Now even though we are using the NAT technique, which is very much useful because the number of IPv4 addresses is small, so still that is not sufficient, because 2 raised to power 32, which is more than 4 billion, that is also not sufficient in today's requirement. So what people are going for is the another type of addressing, which is called IPv6 addresses. So in case of IPv6 address, the total size of address is 128 bit. So you can calculate how many bytes will be there in 128 bit. So 128 bit means we have 16 byte. So the total size of IP version 6 address is 16 byte. Now how this IPv6 address will be represented is, it will be represented, because it is very long, so it will be represented in hexadecimal colon notation, or we can also represent it in binary notation. Remember that computer is going to process binary notation only. Hexadecimal notation, or in case of IPv4 dotted decimal notation, those are the representation or the notation that will be easy for us to understand. Okay, so in case of IPv6, it is either binary notation or hexadecimal notation, but we will be using only hexadecimal because writing 128 bit will be very long. Now how this hexadecimal notation will be we will be getting is, we know the size of the IPv6 address is 128 bit, which is equal to 16 byte. Now, one hexadecimal digit is equal to 4 bit. 1 byte is equal to 8 bit, and that 8 bit will have 4 bit plus 4 bit. This is called nibble, and each 4 bit, the combination of 4 bit is called hexadecimal. One hexadecimal digit will be equal to 4 bit. So that means if we have 16 byte, then how many hexadecimal digit we will be getting? From 1 byte we get 2 hexadecimal digit. From 16 byte we will be getting 2 into 16, that is equals to 32 hexadecimal digits. Right? So how this 32 hexadecimal digit will be represented is, every 4 hexadecimal digit, which is equal to 2 byte, remember, every 4 hexadecimal digit will be separated by colon. So every 4 hexadecimal digit is equal to 2 byte, and we have total number of 16 byte. So how many divisions will be there in this case? Will be equal to 16 by 2, that is equal to 8. So there will be 8 block that will be separated by colon, and in each block there will be 4 hexadecimal digit, which is equal to 2 byte or equals to 16 bits. So let us take some example of IPv6 addressing. Let us say this is my IPv6 addressing in hexadecimal notation, colon notation, and we can also reduce the total size. Like for example, if we have all 4 as 0000, then instead of writing 4 times 0, we can write only 1 times 0. Okay, and we can also remove the prefix 0. Okay, we need not be writing 000 in the front. Now suppose if we have 0 colon 0 colon 0 like this, then instead of writing 0 colon 0 colon 0, you can simply give 2 colon, okay, and with a gap in between. Like if we expand it, we need to understand that there has to be 8 block, and if there are 2 colon like this, then that needs to be adjusted accordingly, okay, to make the total number of 8 block. Remember, we can have this gap only once in the IPv6 address. So these are some way of abbreviating or reducing the total size of IPv6 address. In the next class, we are going to see what are the routing protocol that can be used in network layer, and the difference between IPv4, IPv6 protocols, and so on. Okay, so